As mobile devices continue to become ubiquitous, users' workflows have become increasingly distributed across multiple form factors. Despite their increased integration, devices are ignorant of their roles in a user's workflow. A tablet's behavior remains unchanged, regardless of whether it is being used alone or as part of a task spanning several devices on a user's desk.
We present SMAC, a unified interaction model using user and inter-device proxemics to enable multi-device, desk-centric environments. In our model, we make use of the user's position via the focus of the hand, head gaze, and body orientation. Devices are also aware of each other's distance, either separated or adjacent, and their orientation, either away or towards. This model allows for the support of smooth workflows in multi-device, desk-centric environments. To demonstrate the power of SMAC, we created a prototype system named OmniDesk using the Vicon motion capture system.
This is Jim. He is working in his office as a knowledge worker. He uses multiple tablets, a laptop computer, and a desktop computer on a daily basis. He is about to write an academic research paper using our prototype. First, he wants to read some documents. Each tablet is currently showing a document he is consulting for his research. Because these tablets are outside of his body focus, they show a summary of their contents using highlighted titles and theme colors. In this way, he can find a necessary document. When he turns towards each tablet, its content changes to show more detailed information. He can also categorize the documents with digital labels. The default label displays the current document type. When he taps the label, other nearby documents with the same label start blinking. He can also add more labels by creating it on one document and tapping on other devices to assign it. A new label will be automatically generated for documents within a pile. Jim now grabs a tablet and begins to annotate a document on it. He finds some interesting paragraphs he wants to save for future consultation. A small indicator is shown on the screen because the tablet is aimed towards the monitor. This indicator lets him know he can synchronize his annotations to the desktop. Once he clicks on the indicator, a connection is made and he receives visual feedback about the established connection. While connected, all annotations and highlights on the tablets are synchronized to the monitor. This allows Jim to use the tablet and pen for easy annotation, while also allowing him to quickly transition to the desktop for more complicated editing tasks, all in a tightly coupled workflow. As he is reading, he realizes he needs to see more of the document to better understand the current work in context. To expand his screen space, he grabs more tablets and simply puts them side by side. The green sidebar indicates a connection has been made amongst all the tablets. When Jim wants to consult specific types of information in the files, for example only the figures and tables, he can rotate one of the tablets to landscape, and it will update accordingly. Sometimes he places multiple documents in a pile. He can easily browse the entire pile without moving them by touching the topmost tablet and looking at the target monitor. As each of his tablets is currently displaying a different data set, when he stacks them and presses Import on the top tablet, the data from all the piled tablets is synthesized and displayed on the topmost tablet. To copy a figure from the tablet onto the main document on his desktop, he can hold the figure on the tablet, turn his head towards the desktop monitor, and then insert the figure by selecting Copy Figure from the context menu. As OmniDesk uses the orientation of his head as an approximation for gaze, he can similarly move the application window between devices by simply moving his head. As he continues editing, he realizes that he needs more examples to explain a key concept. To do this, he selects a word, looks at a secondary monitor to show a context menu, and uses this context menu to search his computer or the internet. He invokes the online search function from the menu and finds the information he was missing. While performing another search using the display switcher technique, he can find related data on one of his tablets. After selecting the entry, the device containing the document starts blinking. While writing on his desktop, Jim finds an error in the data on his tablet. Rather than having another mouse and keyboard on his desk, he can simply aim his keyboard towards the tablet so he can correct the mistake. As an important deadline is coming up, Jim has organized his desktop such that his email program is on his secondary monitor so that he can respond to emails from his advisor quickly. He could reply directly by typing on the touchscreen, but it is a slow and tiring process. Using the universal keyboard technique, he can place the tablet on his desk and point the keyboard towards it. The colored icon indicates that the two are now connected. Now he can type on the external keyboard. For a longer email, he taps Project to display, and he can reply on the desktop monitor. He doesn't want to miss any important emails, so he decides to leave the tablet there. This casts content from his tablet to the display. A few minutes later, he receives a new email from his advisor, and by clicking on the mailbox icon, he can reply on the desktop.
We presented OmniDesk, a prototype system that exemplifies our interaction model, SMAC, using focus-based input from touch, head gaze, body orientation, and inter-device proxemics.